L'Hospital's rule, problems involving trigonometric functions. Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. In the previous video, we introduced the L'Hospital's rule and solved some basic problems to help you get comfortable with the concept. If you haven't watched the video yet, then I strongly recommend checking it out first. In today's video, we will start solving problems based on L'Hospital's rule which involve trigonometric functions like sin x and tan x. Such problems are very important as they are frequently asked in the examination. And if you haven't already, please subscribe to the channel. Your support gives me the energy, the motivation to keep making more meaningful and helpful videos like this for you. Every like and comment and share truly keeps me going even under my present bad health conditions. So let's now begin solving problems on L'Hospital's rule involving trigonometric functions like sin x and tan x. But please don't skip, watch till the end, stay focused, and let's master the concept in a very simple way. Before starting, let me quickly remind you of the key standard limits you must remember. Those are limit of sin x by x as x tends to 0 is equal to 1. Also, limit of x by sin x as x tends to 0 also equal to 1. And the next one is limit of tan x by x as x tends to 0 is 1. And also limit of x by tan x as x tends to 0 is equal to 1. These are essential for applying L'Hospital's rule when trigonometric functions like sin and tan are involved. So let's start with solving the problems here. See, the question is evaluate limit as x tends to 0 tan x minus x whole divided by x square tan x. You see here there is a trigonometric term that is tan x here, and very important, the limit is as x tends to 0. So let's solve this in a very easy way. So what is the first thing we do when you encounter any problem of indeterminate form or L'Hospital's rule? We assign first k. That's the first condition. So you see this is a fraction, that's one. Then we assign k is equal to. So we have k is equal to limit as x tending to 0 tan x minus x whole divided by x square into tan x. Now if we apply the limit here, it will be 0 minus 0 whole divided by 0, that is 0 by 0. So we can apply the L'Hospital's rule happily. But again, see, if you apply the rule here, the rule says differentiate the numerator upon differentiate denominator. Differentiate tan x is, as you know, secant square x minus 1. But upon x square tan x, differentiation will be x square into, it's a product rule, x square into secant square x plus tan x into 2x. Again, if the limit is 0 by 0, again for that thing you have to again do the product rule. So it's a mixture of all x square tan x secants will become more and more complicated. Okay, so to avoid the complication, to make the problem solving very simple, wherever the tan and sin comes, we use the limit, standard limit, which I discussed to you in the starting. The limit is, since tan is mentioned here, the limit is limit of as x tending to 0 tan of x whole divided by x equals to 1. What is the limit? Limit as x tends to 0 tan x by x equal to 1. See the condition, limit tan x by x as x tends to 0. See, x by x, it need not be only tan x by x. According to the limit, it can be tan 2x by 2x. It can be tan 100x by 100x. That's also equal to 1 only. It can be tan square x by x square. It can be tan cube x by x cube, or tan x whole square by x square, so on. Or tan 5x by 5x is equal to 1. It applies to all. So such problems we will discuss later in the next video. But at time being, is tan x. So limit of tan x by x as x tends to 0 is how much? It is 1. Okay. So two things to be noted here. One is tan x by x, the limit, the tan x by x is that trigonometric term, and the x is tending to what? 0. That's very important. Now, as I assigned k and we see that the is coming 0 by 0, we can apply L'Hospital's rule. But before that, how to apply this? See, there is tan x here. As I told you, the differentiation becomes more complicated. So using this, what I'll do is, see, I need tan x by x as x tends to 0 is equal to 1. So I need what? Tan x by x factor. There is only tan x here. So what I'll simply do, I will divide by x into multiply by x. That's it. So what I do, I divide by x and multiply by x. So when I do that, what happens? This factor will be limit of tan x by x as x tends to 0 is what? It is 1. It becomes 1. The trigonometric term which was creating the problem by differentiating vanishes and it becomes very simple here. So you can write this as k is equal to limit as x tending to 0 tan x minus x whole divided by x square into x is x cube. So which is more simpler? X square into tan x was more simpler or x cube. Differential x cube is 3x square, 3x square is 6x, 6x, so on. That's all. Okay. So like this, using this limit, standard limit, we make the complex problem very, very easy. Now let's solve for this. Now, as you know, apply the limits here again. So this will be 0 minus 0 by 0, that is 0 by 0. So you can apply L'Hopital's rule. So you can write by L'Hopital's rule, k is equal to limit as x tending to 0. What is the L'Hopital's rule says? Differentiate the numerator upon differentiate denominator separately. So what is the differential tan x? It is secant square x. So right here, secant square x minus, what's the differential 1? It is x, x is 1, sir, upon. Again x cube will be 3x square. Okay. So here, see, I am getting limit as x tends to 0 secant square x minus 1 divided by 3x square. Now, again I can proceed further by differentiating, but see, I'll get the answer. But see, there are some things which makes the solving problem making, it makes it easier. So, in trigonometry, there are 3 important identities which you have learned in your previous years. Okay, those are sin square plus cos square theta is equal to 1. These identities you need to remember always till engineering and thereafter. What are the identities? Sin square plus cos square theta is 1. 1 plus tan square theta is what? Secant square theta. And 1 plus cos square theta is cosecant square theta. So, wherever you get terms like tan square, secant square, you can use those. So, what I told, 1 plus tan square is equal to x is equal to secant square x. Fine. So, what is secant square x now? 1 plus tan square x. So, this will become limit as x tending to 0. I am simplifying first. So, secant square is 1 plus tan square x minus 1 whole divided by 3x square. So, now here 1 and 1 cancels. I get the limit is reduced to very simple form as limit as x tends to 0 tan square x by 3x square. Okay. Now again, how to apply it now? So, this thing become more and more easier now. Why? Because again this is reducing to the same form tan x by x. So, this I will rewrite this as that is equal to k is equal to limit as x tending to 0 1 by 3 into tan square x by x square. And what did I tell you? This limit is so useful. This limit, which limit? Limit of tan x by x as x to 0 is so useful. It's not only tan x by x. It can be anything, but this factor should be same. Tan x by x, 2x by 2x, 3x by 3x, tan x square by x square, or tan square x by x square, or tan cube x by x cube. Same. So here if you see, tan square x by x square is also nothing but equal to what? 1 according to the limit. That's it. Therefore, the answer is, it implies k equals 1 by 3 into tan square x by x square as limit x tends to 0 is equal to 1. So, k is equal to nothing but 1 by 3. That's the answer for this question. That's it. So, you saw how the complicated terms get dissolved here using the simple limits, and the solution becomes, differential become very, very easy. That's it. That's how it's applied. Now, the next problem we will be discussing here is evaluate limit as x tends to 0 e raised to x minus e raised to minus x minus 2 log of 1 plus x upon x sin x. So, this is again having the trigonometric function sin x here, and this x tends to 0. So, Which standard limit will you use? Limit of sin x by x as s tends to 0 is equal to 1. So let's first start solving this. So the first step, assign k is equal to always. So assign k is equal to here. So k is equal to limit x tends to 0 e raised to x minus e raised to minus x minus 2 log 1 plus x upon x into sin x. Solving mathematics problems is like discipline. So follow the discipline, you'll get the right answer. So first assign k is equal to. Well, the next step now, the next step is we check for the limit. E raised to 0, 1 minus 1 minus 2 into log 1 plus 0 log 1 upon 0 into 0. That is again 1 minus 1 0, log 1 is 0. So 0 by 0. It means we can happily apply the L'Hospital's rule here. What is that? Differentiate numerator and denominator. But again, x into sin is differentiation. X into cos x plus sin x into 1, again differentiate one more time. So the product rules, they keep on bothering you. So how to make it simple? We have the limit here. What's the limit used? Since sin x is involved, we have limit as x tending to 0, sin of x by x equals to 1. This is a standard limit used here. Now, it's the compulsory. It should be same as it is sin x by x only. Here there is what? There is a sin x here. So what shall I do? It should be sin x by x and the limit also is there. It is what? 0. That means what I will do to make it sin x by x? Divide by x, and when I divide by x, I need to multiply by x. So when I do that, see, I get a beautiful term here, sin x by x, and limit of sin x by x as x tends to 0 is how much? 1. So the sin term vanishes. Now we are only left with x into x square, which is very easily differentiate. X square is 2, x 2 is 2, that's it. So now let's write it here again. So k is equal to limit as x tending to 0 e raised to x minus e raised to minus x minus 2 into log of 1 plus x upon x square. Now again this will be what? If you apply, obviously it is 1 minus 0 whole divided by 0. So 0 by 0. So we can apply the L'Hospital's rule. So we write by L'Hospital rule. K is equal to limit as x tends to 0. What does it say? Differentiate the numerator upon differentiate denominator separately. Numerator separate, denominator separate. That's the rule. So we do that now. Differentiation e raised to x is e raised to x only minus differentiation of e raised to minus x. See, differentiation of e raised to x is e raised to x. Right? Remember, e raised to x. But it's not here e raised to minus x. People make mistake here. It's not e raised to x. So differentiation of e raised to minus x will be e raised to minus x only. But again into differentiation of, since it's not x, it's minus x, again differentiation of minus x will be minus 1. So minus into minus becomes plus. Again minus 2, differentiation of log x is 1 by x. So log of 1 plus x is 1 by 1 plus x whole divided by 2x. So now I can again put the limits and check. So this will be now 1 plus 1 minus 2 by 1 upon 0. That is again 0 by 0. So again you have to apply the L'Hospital's rule. What does it say again now? Limit as x tending to 0. Again differentiate the numerator upon differentiate denominator separately. So again differentiate e raised to x is e raised to x only. Differentiation of e raised to minus x will be again what? E raised to minus x into minus 1. So it will become minus e raised to minus x. Now see, differentiation of, this is a very important differentiation, remember here. We frequently encounter this differentiation of 1 by x is always minus 1 by x square. Keep in mind, differentiation of 1 by x is minus 1 by x square. What's 1 by x differentiation is? Differentiation of 1 by x is minus 1 by x square. So differentiation of 1 by 1 plus x is minus 1 by 1 plus x the whole square. So yes, minus into minus become plus 2 by 1 plus x square and whole divided by differentiation of 2x is 2. That implies here k is equal to, now finally put the limit. What is the limit? X to 0 here. It means in place of all the x replaced by 0. So what is e raised to 0? It's 1 minus again e raised to minus 0, that's 1 only, plus 2 by 1 plus 0, 1 upon 2. So here cancels, we have the answer as 1. Therefore, the solution of this is k is equal to 1. It is the finite answer. That's it. So the solution we obtained for this question is k is equal to 1. So I hope you understood how to solve this limit. So and I hope you also understood how these two limits, that is the standard limit limit of sin x y x and as x tends to 0, and also limit of tan x y x as x tends to 0 is useful in reducing these forms. So see, it need not be only sin x y x or tan x y x, as I discussed earlier also. It can be anything. It can be sin 2x by 2x, because see, sin x y x, this should be maintained. It can be sin 2x by x, sin 3x by x, that is also equal to 1. It can be sin square x by x square, that is also equal to 1. Okay, since this question is standard, it has been asked many times in examination, I had done this. So they may change the question as sin 2x also. So what to do? You do sin 2x, the condition is sin 2x by 2x should be equal to 1. So you need to multiply by 2x and divide by 2x here, and that makes the factor sin 2x by x, 2x is equal to 1, and you get a desired answer. That's it. So please solve this problem repeatedly so that you don't make mistakes. Especially students make mistake here. Minus, no, they write minus only. See, differential e raised to minus x is e raised to minus x into minus 1. Be careful about that. So that these things only comes about when you practice. So same question, watch it how many times you want, is free, and practice it so that you don't miss anything and you get right answer, and you practice more questions to make your fundamentals stronger. That's it. Okay. So dear friends, that's all for today's session. If you find this video helpful, then please don't keep it to yourself. Share with your friends and classmates as much as possible. Help me reach more and more students. Let's make sure that this knowledge doesn't fade away. Also, subscribe to this channel and hit the bell icon. Take care. Keep practicing as you always do. Happy engineering. Jai Hind. See you in the next video. Bye.